This is Jenny Kunkel, and in this video we're going to cover our database table design, and this is going to be where we cover some of the rules. So when we went through the last video, we had the issues. We try to mitigate some of those from occurring in our database design. Our good database table design is going to be dependent on understanding functional dependency. In each case, I have slides associated to each of these topics. So don't get too wrapped up in the fact that you can't necessarily understand what they are at this point. And we must also understand the normalization process. So when we go through and design tables, we go through a normalization process. Part of the steps are to remove repeating groups when they occur, to remove partial key dependencies and transitive dependencies that are not associated to any of the candidate keys. So in these cases, the last two are going to remove the anomalies that we might see from that prior example and take care of those situations. So those are some of the steps that we go through for the normalization process. For our functional dependency, and this is going to make a lot more sense when we actually take a look at a table example with respect to the functional dependencies, and it's going to be used to maintain the quality of the database. And in this case, it's going to aid in the design by putting some constraints on the attributes that must be true. And if we see here, we have A determines B. That's how we indicate this with our A, with our arrow, and our B. So A determines B, and B is functionally dependent upon A. So that's how we actually say our expression there. And that means that for whatever's on the left side, there's only one value for whatever the attribute is on the right side. And if we think about this in terms of a table design, our A would be our primary key, and it's going to determine what one of our fields are in that table. So each of our fields that would be designed in a table are going to be functionally dependent on that primary key field. Now, in the case of table design, we can have one field that's going to be set up as our primary key. We can have multiple fields that are set up as our primary key because we can have concatenated keys. So we can have more than one field associated on the left side, and that's going to indicate that we have a primary key that is concatenated, and it's going to functionally determine a value in the table. So if we say that we have an employee num, this is going to be determining the employee name and then also the hire date for a row in the table. And then each of the employee name or hire date is functionally determined by that employee number. So when we access employee 1, 2, 4, that employee number is that primary key, and it's going to be functionally determining what are the values that are going to be returned from that table row for the employee name column and for the hire date column. So when we write this, we would say employee num functionally determines employee name. Employee name is functionally dependent upon the employee num. So employee num determines hire date. Hire date is functionally dependent on employee num. So as we look through some of these examples, we're going to have some of this given to us. And based on what we have for our functional dependencies, we can figure out how we need to set up our tables. Now, in some cases, we won't be given the functional dependencies. We'll have to talk with our users to try to figure out what those dependencies are. But in our case this week, when we go through the examples, we will have the functional dependencies set so that we can understand what the relationships are, because depending on what the functional dependencies are that we're given, we could design things a little bit differently. In this case, we have our order num and our order line num. I think this was like from Northwinds or something close to what was in Northwinds. And it's going to have a product ID for the order line number and order num combination that is going to be functionally determined by this key combination. We have the quantity, the unit price, and line total. Again, these are going to be dependent on this order num and order line combination. So we can see here that we would have order num, order line num functionally determines product ID. Product ID is functionally dependent on that order line num. So that was what we would see in that condition. So when we start looking at our normalization process, we have at least a few forms that we're going to go through. In this class, we're not going to go beyond Boyce-Codd normal form. And really, if we're doing our design correctly, we wouldn't even need to go to this level if we take care of it during first normal form. So we have first normal form. That's essentially when we're going to be getting rid of our repeating groups. We have our second normal form, and that's where we're going to get rid of our partial key dependencies. And third normal form is when we're going to get rid of those transitive dependencies. And then Boyce-Codd normal form is if we have multiple repeating groups in our data, that's where we would take care of any of the additional ones if we're not taking care of it within the first normal form. And if we're going to go through each one of these steps, it's going to take us to a good place that we can get to as far as normalizing our data so that we're not going to see any issues with anomalies. We are going to eliminate our redundancy in our data, and we're going to have some good database table design. If we continue on, we have here an unnormalized relation, and this is called software. And it has a package ID, a package name, a tag num, a computer ID, an install date, a cost, an employee num, an employee name, and a location. And we can see here that they've given us the functional dependencies, and it's telling us that the pack ID functionally determines the pack name, the pack ID functionally determines the cost, the tag num functionally determines the computer ID, the pack ID and the tag num functionally determine the install date, the pack ID and tag num functionally determine the employee num functionally determines the employee name, the employee num functionally determines the location. So in this case, if we would try to go ahead and store this as one big table, we would be wrong because, first of all of our data is unnormalized. We have essentially repeating groups. Even though it may not look like it, we do have a repeating group, and that's going to be on the tag num. So we have, in this case, a couple different instances of the same computer that have multiple packages that have been installed, and we need to deal with this kind of repeating group here in order to get it to the first normal form, because the first normal form is where we're going to essentially eliminate any of those repeating groups. So at this point, we typically refer to anything that has repeating groups and is unnormalized as unnormalized relation or in 0NF. Okay, so then we're going to go to our first normal form. And again, this is where we convert an unnormalized relation to 1NF, so one normal form, and you typically concatenate the primary key of the unnormalized relation with the primary key of the repeating group. So how does that work? So if we look at our repeating group, that repeating group is going to be our tag, num, and our computer ID. And if we start looking at our relationships here, our tag num determines our computer ID. So in this case, for our repeating group here, when we have a tag number and the computer ID, if I have the tag number determining the computer ID, I know that the tag number is actually going to be the key of that repeating group. Then I need to determine what is the key of the software relation, the unnormalized relation that's not part of the repeating group. And if I start looking at what I have here, the combination of the pack ID and the tag num indicates that the pack ID is going to be the key of that unnormalized software relation. So in order to transition to the 1NF, I make the primary key to be the pack ID and the tag num. That combination is going to be now the key of that software relation, and I specify it in first normal form with the pack ID and the tag num being underlined. And I'm just going to put the software, which is my relation, those two key fields and then all the rest of the fields there. That's how I would refer to it. Then when I go to second normal form, this is where I have a relation that's in the second normal form if it is in the first normal form, and there are no non-key attributes dependent on a portion of the primary key. So what the heck does that mean? Well, I have my pack ID and my tag num being the whole entire primary key. So if I have any relations that are based off of just the pack ID or just the tag num, I need to remove them into their own separate entities. So let's take a look at what we have, our functional dependencies. So we have our pack ID functionally determined pack name. That's not a combination of the pack ID and the tag num. So therefore, I need to move the pack ID and pack name to a separate entity. And as we continue on here, I have my pack ID also with my cost, so the cost comes down with my pack name and pack ID. So I create a separate entity, and this is going to be packages, and this is just going to be the pack ID, the pack name, and the cost. Then I remove it from my software. We can see that I no longer have pack name and cost in here. I still have my pack ID and tag name that are the key to that software relation. And then as I continue through here, I have my tag num determines the computer ID. Okay, well, tag num is just one of the two fields. It's not both of them. So I have to remove that into its separate relation. And then as I continue through here, I have my pack ID and tag num functionally determining install date. So that stays in the software relation. I have my pack ID and tag num functionally determining the employee num. So that stays in the software relation. And then my employee num is going to functionally determine emp name and employee num functionally determine location. Now in those cases, they're not part of any of the keys, so there's no partial dependency, so I leave them where they're at. So at the end, I'm going to have my software that has the pack ID tag num with the install date, employee num, employee name, and location. And then the other two references for my relations or entities are going to be the packages and the computer. So now everything at this point is in second normal form. Then I need to look at the third normal form, and this is going to be an attribute or collection of attributes that determines another attribute is called a determinant. And the relation is in third normal form if it is in second normal form, and the only determinants it contains are candidate keys. So in this case, if we have something in there, like we have our employee num that determines our employee name. We didn't remove it before because it wasn't based off of our primary key and being a partial dependency. Well, that's going to be considered a transitive dependency, and we're going to need to remove it in order to get to third normal form. So when we are here, we have our employee num, our employee name, and our location. Based off of our functional dependencies, we have our employee num determining our employee name, our employee num determining our location. Those need to be removed into a separate entity, and we can see down here that we've moved it. And the key is going to be our employee num, and we're going to have the emp name and location within the employee table, and that gets removed from the software. The only thing that we have left in our software is our pack ID, tag num, install date, and the employee num. And at that point, once we take care of those last two functional dependencies and relocate them into a separate table, then everything is in 3NF, and we are good to go from a design perspective. We have fourth normal form, and this is where we are dealing with multi-valued dependencies, and that means that if we have more than one set of repeating groups, we have multi-valued dependencies. Okay, so typically we resolve that at 1NF and not at 4NF, which is kind of where they're repeating it at. And this is the process of looking at a problem with multiple repeating groups. And in the case of multiple repeating groups, we see it using two different arrows. And this is basically indicating that within this faculty, we have the faculty number determining the student num, and we have the faculty number determining the Commerce code. And that would be separated into two different entities each one keyed by that faculty number. So this would be for the student number and then for the committee code as well. So we can handle this at 1NF and then not worry about it at 4NF. Our goal is always going to be to normalize to 3NF. Generally, it's enough. We don't need to go to 4NF in a lot of cases. And our physical design, once we get through with it, sometimes once we have done everything to 3NF, it seems perfect, and then we start having some query performance issues. At that point, we would have to weigh the issues of rolling back to a 2NF for performance versus some of the update anomalies that we would potentially run into and determine whether it makes sense for us from a query perspective that we need to get the performance out of our queries to roll back to that 2NF. But typically, we always go to 3NF. We let the performance then indicate once it's in production and working for a while to determine whether we would go to something other than 3NF in our design. Now we're going to go ahead and look at one more example in this video, and we'll go through separate examples, but this is going to be another one just so that we can hone in on those rules. If we look at this, we are seeing that we have an order ID, supplier name, product name, unit price, quantity, and order date. We have dependencies with an order ID and product ID. That's going to functionally determine the supplier ID. It's going to functionally determine the quantity. It's going to functionally determine the order date. Now I have the supplier ID functionally determine the supplier name, product ID functionally determine the product name, the product ID functionally determine the unit price. So if we look at this, we kind of see here that we have a repeating group with our product because we see that we have a 3001, 3001. Typically, if we had more data, it would probably be more apparent. We also have repeating things with our supplier and supplier name. But because we have our functional dependency based off of the order ID and product ID, we know that the product ID is our repeating group here. And we need to then understand that because we have a repeating group, we are at 0NF, or we are at an unnormalized relation. We always don't start out at unnormalized. Sometimes we start out at 1NF, but in this case, we are at 0NF. And if we come forward, we need to make the order ID and the product ID the keys to those relations. Once we do that, we're essentially just going to create our order entity with our order ID as the key and our product ID as a key, and then translate all of the other fields in it, and we are at 1NF. Then if we continue on, we're going to separate those out into their own relations just to make it a little easier to understand. In a lot of cases, we just use the documentation like this instead of trying to create multiple tables. But in this case, I think it makes a little bit more sense to see them. We have our two relationships, and we want to move to 2NF. And in order to do that, we need to remove any partial key dependencies. And if we look at our functional dependencies, we have our supplier ID determining supplier name. Well, that's not dependent on the order ID or the product ID, so we just skip that at this point. But we do have our product ID that is essentially going to determine the product name. We have our product ID that's going to determine our unit price. Therefore, we need to move out of the order relation into a separate table, the product ID, the product name, and the unit price. And we're just going to leave the product ID there as the key. Then when we move this, because the product ID is functionally determined the product name and the unit price, that's going to be our key to that entity. So once we do that and we move it out, and we see here that we have the product reference down here and we have our order here, same thing as what we're seeing in the table, we're at 2NF. The only thing we need to do is we need to go to 3NF. And to go to 3NF, we need to remove the determinants that are not based off of that primary key. And we already kind of looked at one because we saw that the supplier ID determines a supplier name that wasn't dependent on the order ID and the product ID. So that is the determinant that's not dependent on a part of that primary key, and we need to move it out into its own separate relation to get to 3NF. So in that case, we would move the supplier ID and the supplier name to its own entity and then remove the supplier name from that order table. Once we do that, we are at 3NF. We are at a good table design at that point. Now we're going to go through a bunch of additional examples in the next video. Some of them are going to be a little bit more abstract, but I think it's going to give us the practice that we need to see how we can identify what form we're at to begin with, and then where we need to go to get it to 3NF at least.